Morning! We're out here in the other workshop, and you can see what I've been doing. It's not too bad out here this morning. The sun's actually out. It's been raining for about 4 days. So you can see here that I've started to kind of mock up what it is that I'm actually trying to build. Excuse me. I've got a little bit of a frame that I've created, and I've bolted my motors into the frame to see how they're going to sit and what sort of ground clearance I've got. You can see my drive sprocket here. Now the idea is that the drive sprocket will fit on this little spline that comes out from the motor at the moment. It's just kind of resting on the bolt that comes out, which isn't really much good. I'm going to have to find a way to make some sort of sleeve that comes out on this that will then fit on that and that will support this weight, because this is quite weighty. And then obviously over that, you can see I've worked on these, cut out all the second teeth. So I've now got a different shape drive socket, and obviously my chain will sit over that like that, and that's how that will move, and that's how that will drive. So that's kind of the drive, not done, but we're a fair way on that one. That sits on there like that. This is going to be a problem. Well, there's lots of problems. I say it's going to be a problem, but I like solving problems, so it's not a problem. Well, it is a problem, but I'll solve it. Anyway, the way this works is wheelchair motor. So basically, what you can see here is I've mounted the wheelchair motor into this frame. And let me just take the pin off there. Oh, sure, I could leave that on. So the wheel, normally the wheel will go on a wheelchair motor, goes on kind of like that. It goes onto there. So that whole piece, it's getting a bit heavy already, this thing. That whole piece slides onto this shaft here, and then obviously there's a threaded piece at the end, and that just locates the wheel on. It keeps the wheel on that shaft, and then there's this little Woodruff key that clicks in there that clearly stops the wheel. It locks the wheel to the shaft. And you can see that it's quite, I can't see on the camera, it's quite deep. About 4 or 5 centimetres, and that's what engages. Now, these wheels are rated for 300 kilos on the wheelchair that came off. Now, what that means is that effectively 300 kilos of weight can be placed onto that shaft without it breaking. So there's no way I'm going to 600 kilos of weight is going to be on this. It's just not going to happen. I mean, that's over, it's over half a ton. So my issue is I've got to get this onto there. But there's no way I can just bolt that to that tiny little thread, because the first thing that will happen as soon as it's under pressure, it will snap off. So I've come up with a method. I've made basically this little collet sort of thing, I think they're called, that will just slide on there. So that's kind of been machined. I've just made it out of this, got a bit of tube, hammered it all down, shaped it all down till it was the right shape, and put the slot in it. And that now slides on there. What I should be able to do is I've got to then weld that. I can take this obviously all apart. I'll weld that onto that. So when this then, as you can see there, look, when this goes onto that, it will go on and locate onto the shafts, which means I won't have any issues of it bending there. Obviously the weld is going to be really important. So I need to make these little flanges to go onto these drive pieces, but to centre it all, instead of doing it off the bench, I did it on the motor, and I made a huge mistake. I touched, the weld dropped through a tiny hole onto the inside of the shaft, so I've just had to grind all that off now, and hopefully now it is all square still, because if I've gone off square, yeah.
Master Maker, what you got?
Batteries.
Batteries. Ooh.
And a very nice 24-volt charger.
Thank you, supplier. You were brilliant.
Yeah.
For free. Unboxing of batteries for the new project.
So normally I would use these kind of batteries. Weight, yes, can be a problem. It depends on what you're using them for, but the difference in the cost. 2 of those would cost me 80 quid. 2 of these cost me a lot more than 80 quid. So I think these come in about £170 each. So don't tell Mrs. Breaker yet.
That's the maker. Do a weigh test then.
So I've just bought these. Life EPO4, 22 amp, 12 volt. 2.8. 2.5. 2.85. That is the equivalent lead acid. You can see they're exactly the same. 22 amp. So that is the equivalent lead acid.
5.8.
5.8. So 5.8 kilos for one. And obviously I'm going to need 2 in the build. So 2 of these. About 5.7. Right, so I am mocking up the wiring at the moment. I wanted to test the speed controllers and just test the battery system and the speed control. So as you can see, I've got it set up now. It's kind of all mocked up. I've got breakers here, breaker here. What I'm now going to do is connect the speed controller. See the little fan going around. The radio is there.
Telemetry recovered.
Telemetry recovered, and you can see when I push forward on the stick, we have power.
In fact, Zoe, the whole top is made from recycled stuff.
The whole thing, though.
Well, no, apart from these, we bought these. These glockenspiel bits we bought.
Well, I could have done it, we don't. So you see all that stuff in there.
Could have done it with, yeah, all this junk.
Well, it's not, because the aluminium, I'm going to cut that into the panels for the armour.
Oh, right,
So I
okay.
will stick hundreds of those pieces of aluminium, which I'll cut out, which will take me months.
Good.
They will be stuck in little squares all over to create lines of the armour.
Of the armour, yeah, no, because they're coated. What happens if it doesn't work?
Ready then? 3, 2, 1.
Yeah, that's loud.
Right, so I'm working on the actual gun breech system. And you see what I've done here. I'm going to give you an example. I've used a bit of this tube, and then the primer system is going to go into the tube like that, which will then hold it in the tube. So what I've done there, in the end of this, is I've welded in a little mechanism. So that will now sit in there like that, and that will be locked in place. Little screws being welded on the top, and that will lock that now in place in there. And the way this will work is there'll be a servo that will be mounted here, and what the servo will simply do is, as it moves, as it rotates like that, I'll just pull the pin out. Right, so I'm here on the workbench and I've mocked up the firing mechanism. Now, the G-clamps are just because it would normally be fixed in the gun. This little G-clamp is just holding the servo in place. This one is just holding the whole mechanism to the bench. You can see here the mechanism. The firing unit is actually in there. Now, it's actually primed. There's a charge in there. There's a primer round in there. And you can see the mechanism here and the way it's going to work. The servo is going to move in that direction, which is going to pull the firing pin out, which is going to fire the round. So we're going to demo this now. Hopefully this will work. All I've got to do is move the stick on the radio. But before I do that, I'm actually going to move back out of the way, because remember, this will all be encased in metal inside the gun. You probably won't get a smoke effect because there's no barrel attached. So here we go. I'm going to move back and we'll see if this works. 3, 2, 1. It worked. That's really cool. I think when the barrel was on there, and you saw there was a little bit of smoke came off, when the barrel is on there, and when I've got the extraction system pushing the smoke, it will push the smoke out of the barrel. Now, interestingly, to reprime it is as simple as this will eventually just be a little wing nut. Undo it, take the unit out, discard the old charge, put a new one in, put that in there, fit that back in there. The big bit of string is just to help prime it. Pop the pin back in, and then there's no charge in there. We can go through the whole process again. Right, the system that you saw on the bench is now in the tank. We're going to have a go at firing it in the tank and see what happens. As I said, yeah, let's see what happens. Okay, then 3, can't remember which way the stick goes now. 3, 2, 1. We got a tiny bit of smoke. Tiny little bit. Nice big bang. I think, did you notice that when I blew the smoke out there? I think with an active system in here of pushing the air out, it'll be really good. It'll be really good. Right, so this is the soundboard that I'm going to use in the tank. DYHV20T. I don't know whether that's a thing or not. They're incredibly cheap. Normally I use the Spark Fun boards, which are about £65. This wasn't £65. This was £7.50. So no, £8 basically. Now I've soldered a few bits onto the headers here. So basically what I've done, it can take up to 12 volts. This one, so 12 volts coming straight off into just a little 12-volt battery. That will power the unit up. I had another one before this, and it didn't work. Slightly different model. This one is really good because when you power it up, you actually get a green light on the board, which is really nice, so you know it's actually working. And then obviously, let me just turn that off a minute. I'm going to run it. I'm not running it on the internal speaker. Now you can connect just the speaker to it directly. It's got a 20-watt amplifier on it, but I'm going to connect it into the big JBL here. So it's just running in, you know, as normal. Power it up, and I've got a couple of sounds on there. Now the way it works is you can just trigger these things here. So the ground is connected to that wire there, and then it moves along. So 1, 2, 3, 4, 5, 6, 7, 8. It can trigger 8 sounds. So if I just touch those two together, we just get a sound. So that's sound number 1. It's that simple. It's a trigger. Now, the idea is that these two wires, or all of these wires, will then go to either RF relays, or they could go to some other switching device. So you could remotely then switch this soundboard. And I'm actually quite impressed with the speaker as well. The little 20-watt amplifier in that is actually quite powerful. So obviously, once that is was in an enclosure, it might be reasonably powerful, or powerful enough for a small project. So for sort of basically less than a tenner, this is awesome. So you can kind of see the internals here. So the idea, you've got the motor going through a little transfer box into the ring here. If I run it, you can kind of see. motor moves the little transfer box, which then moves this. And the way basically it's done is it's one of these things that go over cameras to do the follow focus. And I've kind of glued one around the outside of the Lazy Susan, and then it's running off this little transfer box that I've made, which is just another gear that acts on this surface, and then it's driven at kind of right angles, I suppose, I don't know how you put it, to this. The problem I've got, this stuff is incredibly hard wearing, so I'm not worried about this because it's very, very flexible. The one I'm worried about is this, and it's the weight that is on this bearing, and what it's causing this to do is to slip. And you see this kind of movement here in the bearing. That tiny amount of movement is causing this to move away from that. So I think this needs to be sprung so that when this engages on it, it pulls better. But you see, I think it's pulling away at the moment. The torque of the motor is moving it away. So I need to find a sprung system to push this harder against this. Right, so I'm playing around with the turret motor. You can see the idea is don't like that noise. The noise is coming from, I'll show you in a minute, but it's because of the weight of this. Right, so I had a little bit of a problem. I showed you my design, which had this with this engaged on it. And the idea was that I was driving the motor off that end piece there, so that turns. So this little gearbox in here blew up. It's just not strong enough. Also, I was a bit concerned about this. This is kind of 3D printed, and there's parts of it have melted, and it's just not, it's hard to see on the camera, bits of it have actually melted. So what I've done is, this is plan 2. I've mounted the motor vertically on a massive big clamp and used an old chuck, an older drill chuck, and then glued some more of this stuff. So this is the stuff I'm using, like I said before, it's this flexible plastic. It's actually really, really strong. So that's kind of glued around there, and then I've also glued a bit around this, and I'm driving it now direct. And I must admit, I've got it all mocked up here just to a speed controller. It's much, much better. It's much more direct. There's a couple of problems which I don't know how to overcome at the moment. There's a little bit of movement. The motor that I'm using is an old drill, an old 12-volt drill which I had years ago, and this literally is an old 12-volt drill chuck, which I've taken off another drill. I had it in a cupboard somewhere, and I've turned it upside down, clamped it on, and I've glued this around. So there's a little bit of movement in it, and also the torque in it is phenomenal. But what I have noticed is it works better with the top on. So I'll put the top on and I'll show you. Okay. Right, so I've got the top on. It's not really all tweaks, but you can see now there's much more control. There's a tiny bit of slack there, and that's the way that these motors work. But that's not a bad thing, having a tiny little bit of slack in that movement there. So let's just put a little bit of you can hear it on my mic. If I set it, you can hear a little. See that moment where it takes up the slack. Much stronger. So the clutch, this little gearbox, it was just, there was a couple of little planetary gears in there, but they've just, there's not much left of the planetary gears, to be honest. That works much, much better. The only thing that I am getting, which is unbelievable, is the motor. I'm still getting actual movement in the body of the motor, because literally the torque that goes through. So when it changes direction, there's so much mass here. But hopefully I might be able to offset that with something. I don't know. But that's 1,000 times better than it was.
I have a question, Master Maker.
I have a question from the audience, yes?
When you put the big, long, enormous bit that sticks out the front, the tubey thing
The
on,
barrel.
will it not cause more force?
No. So
thing?
this is really very, very strong. I can't move this. I don't want to, obviously, I could just pull it and it will take the teeth probably off the... But then saying that...
But surely if the thing is long, you'll get more operational force.
It doesn't weigh anything.
No. Okay.
I mean, you're talking about the barrel, the actual barrel, which I've got. I did have.
There it is there.
So the barrel here doesn't literally weigh anything. I mean, the heaviest thing is actually this piece here. So there's no weight, and obviously there's not much weight on it at the moment because we've got all the other bits and pieces that are going to go on. I can put the barrel on. As you can see now, it really makes no difference. It's certainly better than it was. There's bits gluing on it, so don't. This is all being glued. This stuff. So I've stripped the whole tank down again, so you can kind of see now all the stuff inside. Smoke machine goes in there. That's the drive motor for the turret. I'm sealing it all now because the idea is that the electronics should be on the lower section about level just under the top track there. So that means, get me tape measure, just double check. That means it should... That is 140 mil. It should be able to go underwater to 140 mil. So that means it should be able to go through quite thick mud and stuff like that, up to at least 100 mil. And the electrics, which for the drive, will be in there. So they'll be out of the way. I can't really get them any higher, that's the problem. And then the back of it all, so that you can see here how it all works. This is then obviously the top section here. And that all goes on that. This weighs quite a bit already now. It's quite heavy. So, I reckon, well, it's about 30 kilos, isn't it, that? And then all the other bits are over there at the moment. So, yeah. So I've got to put it all back together, because that's all dry now. And then, got myself a new trolley as well, look. It's really cool, isn't it? Means I can move it around. Look, 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 look. Mrs. Breaker made me buy it because she said, well, I'm not exactly going to say exactly what she said because that wouldn't be broadcastable, but she said, I'm not lifting this thing into the car, so you have to find another way of doing it. It's a bit squeaky when it goes up, I must admit, probably needs a bit of oil or something. But it only goes up that high, which is good because the car's only that high. And then in theory, should just be able to drive into it. So it weighs in now, with everything on it, about 96, 95 kilos. So it's quite heavy. Heavier than me. Right, anyway, better get on. It's kind of like a side project for me, This is just something that I've wanted to build, and it's a side project. It's not built for any show or any particular reason. It's built because I want to build it. It's that simple. But I'm going to have a bit of fun with it, putting some of the tech in it. And as I've always said, if you're going to build something full-sized, best to build a model first. Anyway, here we go. Watch this. It just produces... It's not that bad, actually. See you later.